So again, so this is the part 3 of our lecture video series about work and conservation of energy. So last time from our part 2, so we stopped at the properties of a conservative forces. So conservative forces, example is the gravitational force and the spring force. Okay, so yeah, there are 4 properties. And remember that if only the conservative forces are present or do work on the system, then the total mechanical energy is constant and conserved. Okay, so yeah, that's the example of conservative forces. But what is the difference of the conservative and the non-conservative forces? So if ang imuhang conservative forces offers a two-way conversion between kinetic and potential, si non-conservative forces cannot do that, cannot move from kinetic energy to potential because the non-conservative forces are mga forces nga depend sa imuhang path. Okay, so unlike sa imuhang conservative forces, ang work done is only depends on the final or the initial and the final points. Pero sa non-conservative forces, ang work done niya is depends on the path. And one of the common example in mechanics of non-conservative forces are friction. So any type of friction, air friction ba na siya or surface friction. So this friction are non-conservative forces. Okay? So what do you mean by non-conservative forces? So friction also is called dissipative forces. So just like what I said. Okay? Okay. Dissipative forces meaning that it always kuha og energy sa imong system, di ba? Sige siya kuha og energy sa imong system until such time nga mo stop na imong system. Di ba? So just like if imong object nag-move in a friction na surface, so of course naa siya kinetic energy and potential. So if mo move ang imong object with a kinetic energy, it will eventually stop due to friction. So kung wala na siya friction, of course, continue lang ang motion according sa Newton's law of motion, di ba? Kung wala friction. Pero mo stop siya because of friction. One thing that we can explain this one is because the friction always opposing the motion. Okay? So always opposing the motion and always kanang dissipate energy or from the system. So meaning that kung mag-dissipate siya energy, kinetic energy for this case, so it will eventually stop kay mahulot naman ang kinetic energy. Kay wala na siya energy nga move through in motion. Okay, because of friction. So mo na ang anang mga example sa non-conservative forces. So friction also, so for example, is depend on the path. So this is from point A to point B. So if I have to move straight A to straight B in a naay friction nga surface, so of course naa kay friction dali, work done by the friction. Pero if mag-move ka paana, pero they have the same initial starting point, of course, the friction nga ang na-loss nimo here, the energy that you lost due to friction here, is greater than the energy loss nga na energy loss by friction due kung straight line lang ka. Diba? So lahi ang iyahang work done by the friction here o work done by the friction here. Okay? Because the work done depends on the path. Okay? So there are many types of friction. So dili lang ang non-conservative forces nga always siya magkuha og energy. Dili siya na po yung mga non-conservative forces nga mo increase pod ang iyahang mechanical energy. Okay, so just like here na kung giingon asa man to nara, if work done by other forces is positive, then the mechanical energy increases. So naay possibility nga mo increase pod iyahang mechanical energy. Okay? So yeah. That's the That's the kanang properties of a conservative force and a non-conservative force. Okay? So let's go naman sa the totality of the conservation of energy. Kay kato siya, that is the conservation of mechanical. Then mechanical energy is composed of kinetic energy plus the potential energy. So mo to yung mga mechanical energy. And we know there are many types of energy. So we have the sound energy, light energy, naatay uh, thermal energy. So there are many form of energy. So how can we account this one to give the total definition of conservation of energy? Dili lang ang mechanical energy. Okay? So the energy associated with the change of its temperature is called the internal energy. So internal energy is actually the uh, depends on temperature. So meaning that if the internal energy, if the temperature increases, then the internal energy also increases. And if the internal energy decreases, then therefore the temperature of the body decreases. So just like the friction, di ba? So once nga magkuha ang imuhang energy, once nga magkuha ang imong friction ng energy sa system, so for example like this one, na mo stop na imuhang for this case, mo stop na imuhang body, so ang energy is wala siya nawala. Wala siya kanang magically nga niwala ba. Okay? So naay energy nga na loss, pero ang na energy nga na loss is actually uh, converted to heat energy. So mao nang kung imo nang ikapon ang lubot ani nga kuan kaning surface ani nga kuan nga object, then mafeel mo ang init because the kinetic energy converted to heat due to friction, diba? So mo na ang internal energy. So the change of your internal energy is actually equal to the negative work of others. So it could be friction, it could be the applied force or anything. Okay? So basically yung internal energy mo is associated naman with temperature. So hindi pa ito yung yun ka ng other badang pa tayong other forces bitaw ay other energy bitaw. Pero anyway, so the law of conservation of energy states that the total energy of the system is equal to zero, meaning that the energy is never created or destroyed, but it can only change from one form to another. Okay? So yeah, kabalo mo how to what is the mechanism of having light, 'di ba? Electrical energy, mechanical energy. So 'di ba mao man ang mga kuan, mga uh, it changes only from one form to another, 'di ba? So dili siya ma-create, di pud siya ma-destroy. Okay, dili siya magically created, di pud siya magically nga nawala dito kay because even though mo ini kog dissipate, so dissipate is a very kanang confusing term because when we say dissipate, nawala na gid ang imong energy, but actually wala na wala mong energy. It actually converted to heat lang. Okay, due to friction. Okay, so meaning that the energy in motion is now converted to heat energy. So basically, nag-change siya to other form. So mo nang pasabot na law of conservation of energy. Okay, so there are also many types of form, di ba? So kanang sa inyohang geothermal, we use heat energy para maka-provide og electrical energy sa ato ang kuan, maka-distribute sa ato ang mga appliances like so napa other form of energy. So basically ito yung totality ng law of conservation of energy. So this can only like mo increase siya, mo decrease, mo increase as if you add all of them dapat equal siya sa zero so that wala gi-violate ang law of conservation of energy. Okay, so pwede siya may mong zero, pwede siya mo increase, pero at some point, kung increase ang kinetic energy, dapat naapoy mo decrease silang duha so that para ma-maintain nila ang equal to zero ba? Diba? Kaya para dili nila ma-destroy or ma-violate ang conservation of energy nga law. So remember, ang law of conservation of energy is very important. Okay? Okay, because it actually like provide an umbrella of the of physics community. Meaning that if you have a theory, then you violate the law of conservation of energy, it is basically like na something wrong sa imong theory. Okay? So dapat naagid kay law of conservation of energy, it will not be violated. Even the universe also kanang even the particles tanan system also kanang ni kuan siya kanang ni sunod siya sa law of conservation of energy. It follows the law of conservation of energy. Yeah, I think that's it. So we have to move on to our example. Ito sa itong example. Okay, so first example, we have to apply the conservation of energy. So example 1. So a small rock with a mass of 0.20 kilogram is released from rest at point A, which is the top edge of a large hemispherical bowl with the radius 0.50 meters. So always remember ha, kung makita mo grams or centimeter, you have to convert that one to SI unit. Okay? Para dili mo malibog sa unit kay marong man yung answer. Okay? So dapat inyo siya kung makita mo wala sa SI unit, i-convert sa niyo sa SI unit. So the work done by the friction on the rock when it moves from point A to point B is 0.22 joules. How much work is done on the rock by normal force and gravity? Okay? So here we have to find the work done by the normal force. So first, I will just use my pen. The work done by the normal force. What is happening? The work done by the normal force, so di ba naamang kay hemispherical bowl. Okay? So diri ang imuhang A, so naa siya radius like R, so assuming that your ball is very perfect, nga wala siya something para we know that all of the radius in a circle, even though it is a semicircle, so the radius is constant all throughout, diba? So naa kay rock dari. So the work done by the normal force is always equal to 0 kay nga naman because kung asa imuhang system mo man ang surface, di ba? It is always perpendicular to the surface man. So the motion or the displacement is in the same it is perpendicular with the normal force always from point A to point B. So therefore, the work done by the normal force is always equal to 0. How about the work done by the gravitational force? So yeah, we have to find the work done from A to B. So that is, we have to let our B here to be our height B or YB, which is a ground level equal to 0. So remember, ang atoang potential energies are based on your not only based on the configuration but also based on your reference level. Okay, so for example like this one, dili necessary nga ang atong ground is always at reference level. Pwede po, for example like for our case, na siya sa bottom of the bowl. Diba? Pwede na to siya atong himuog reference level which is equal to 0. Diba? So if we have to find the work done by the gravitational force, so that is equal to, we have here mg, tapos we have y1 minus y2. So use our expression dun sa atong kwan, ato ang system equation sa ato ang slides. So here, the work done is always in the same direction as the displacement, diba, motion. So the force here is going down, so we have the weight. So is it like always nga kanang perpendicular? Hindi siya perpendicular, di ba? Because the object is always moving in the same direction as your displacement, di ba? So here remember that we only have to find the work done by the gravity as the negative change of your gravitational potential energy. So, dili na to kailangan ang path. We just need like an initial point at saka starting point. Okay? So, we have here the gravitational potential energy at A, the initial, minus the gravitational potential energy at point B, the final. Okay? So, at point B, wala, zero man na ang atong height dire. So, basically, zero po ni siya. So, how about the gravitation at point A? So, we have mg, tapos the height at point A. So, we can put this one, the height at point A. So, the height at point A, so the height A is actually equal to the radius. Okay, assuming nga ito ang spherical bowl is a perfect circle. Okay, I mean, a perfect semicircle. So we have mg, tapos we just have to, our HA is actually equal to R. Okay, the radius of the hemispherical na bowl. So what is now the work done by gravity? So we have the mass, which is equal to 0.20, the acceleration, and the radius is actually equal to 0.5. So how much is that? That is equal to 0.98. So the work done by the gravitational force is equal to 0.98. And the unit is joules. Okay, so letter B. So what is the speed of the rock as it reaches down the hole? So assuming again na okay na siya friction. So we have to use katong 1/2 mv1 squared plus mgy1 plus the work other, which is only the friction lang ang nag-work other than gravity, is equal to 1/2 mv2 squared plus mgy2. Okay? So our initial point is our point A and our final point is point B. So we can replace 1 to A and we can replace 2 to B. Then we have to like atong tanawon kung nabay kinetic energy here at point A or potential energy at point A, nabay kinetic energy at point B, or wala naabay potential energy at point B. So we have to evaluate kung unsay na ang energy present at that point. Okay? So at point A, at rest man ni siya, di ba? Ingon man sa problem nga V is released from rest at point A. So meaning, of course, wala siya potential energy. So meaning that VA is equal to 0. I mean, wala siya kinetic energy, Pero, na siya potential energy, which is equal to the gravitational potential energy. Okay, what else? So how about your B? At point B, wala na siya potential energy because the height is 0 naman. Diba? Kay mg times the height. If the height is 0, then the potential energy is 0. So HB is equal to 0. Excuse me. So therefore, there is no gravitational potential energy. Okay? So evaluate. So we have 1/2 mVA squared plus mgh1 or y1 plus the work done by the friction is equal to 1/2 mvb squared plus mgh2, or the HA then is, or HA, tapos kani siya is HB or y2. Okay, so at point A walay velocity, so this is 0. At point B wala siya height kay reference level, so wala siya potential energy. So our unknown is we have to find the speed at point B. So mga itong unknown. But ang work done by the friction is actually equal to 0.22 joules. So remember that the work done by the friction is negative on this configuration. Kaya nga gani? Because the motion, the friction is always opposing the motion. Okay, so we have to make sure that the work done by the friction is negative 0.22 joules. Okay, so we have to put all together our ato sang ikuan, ato sang si VB. So we have VB squared. So we have to multiply by 2 over m on both sides of the equation. We have 2 over m. Then we have here mgHA plus the work done by the friction, and taking the square root of both sides of the equation to get VB. So your VB is equal to the square root of 2 over m, then mgHA plus the work done by the friction. So then calculate VB. So what is VB man? So we have 2 divided by 0.20, the mass. Then mgHA is actually equal to the work done by the kuan lang, by the work done by the gravity, which is the mgr, diba? So can I just write this one directly here, kaya di na ta madugay. Okay, so we have 0.98 joules, and the work done by the friction is given by 0.22 joules. So what do you think is the speed? What do you think is the speed of the so please, so I just want you to put all the values ha. Okay, so kung namoy kuan diha, ikuan lang ko ninyo. So taking the square root, so that is equal to 0.87. So that is equal to, is it equal to 0.27? Just wait. So this must be work done with friction is negative. So negative naman ni siya. So pag ato ito, ma-positive na siya. Right? I think wrong atong pagkuhan. Wait lang. Because it is 0.87. So can I just, so anyway, so ayun lang siya ko ana. So focus on sa disa muna diri. So mgHA plus omega f. So diha sa ta mgHA plus omega wf, mgHA plus wf, then we have 1/2 mvb squared. So the mgHA is 0.98 minus 0.22. How much is that? That is equal to 0.76. Okay, so we have 1/2 0.20 vb squared. So I think same na gyapon, no? Yeah, same lang gyapon. Yeah, same na gyapon. So the vb is actually equal to, so sorry about that. 1 to sa result. May siya. So anyway, naman siya friction, so relatable lang siya. This 2.75 na po. Okay, so what is happening? Yeah, 2.76 answer. So the VB is 2.76 meters per. Okay, so I think muna na siya. So the next part is we have to what is the maximum height reached by the rock as it slides down to point C, where point B to C is frictionless. So wala siya friction from path B to C. Okay, so we have to make sure nga we have to evaluate kung unsay naa nga energy present at that points. Okay? So, at point B, of course, naa siya velocity, pero wa siya potential energy. Okay? So, at point C naman, eventually mo stop man atong object, di ba? So, find the maximum height man. So, it is where we stop na ang imong rock. Stop na siya at certain point. So, therefore, the potential energy is naa, pero ang imuhang velocity at point C is 0. So, wa siya kinetic energy. And there are no other forces except for gravity present sa path B to C. So, we just have to use directly katong 1/2 mvb squared plus mg hb is equal to 1/2 mv c squared plus mg hc. Diba? So, kani siya is the initial na. Okay, from point B to C naman ta. Diba? So, from point B to C na ta, this is the initial, this is the final. Okay, so ako siyang gilisan. So, there is no potential energy at point B, so this is 0. And there is no kinetic energy at point C, so this is 0. So, we have to find the maximum height or HC. O na itong pangitaon karon, the maximum height. So, we have 1/2. So, we have to cancel M. They are common to both sides. So, we have here, this is the HC. So, we have VB squared over 2G. So, what is your HC, man? So, VB, the velocity at point B, is we have to refer to our result here, which is equal to 2.76. So, we have 2.76 squared. So, the height is 0.39. So, 0.39 meter. So, you might ask, nga nganong wala man siya dili sa point C na answer na tumong, which is the height niya is 0.5. Because, nakuha na mag-energy dili from point A to point B, kay tungod sa friction. So, we have to expect na dili siya maabot dili at the point C. So, naa siya middle sa 0.38 here, mga anak gulo. Kaya kuha naman siya energy sa friction dali, so di na siya makaadto exactly sa point C. Pero, if wala kay friction diri, so basically balik na siya na point A, B, C, ana na siya. Wala friction, balik ana na. Okay? So, since na friction, then you will expect na ang imuhang maximum height is less than the initial height kung asa siya ga-start. Okay? Okay, so I think that's it. So let's move on to another problem. So this is like the combination of elastic force, the gravitational force, and I think there's no friction, so wala tayo friction. So katurang spring and gravity lang ang nagduog work on the system. Okay, so we have this one. So wala na tayo point A, point B, and point C. So, para madali, masindot kung ato siyang i-chop-chop ang event. Okay? So, first event, we can call this one as our A. So, here, a 2 kg block is pushed against a spring with negligible mass and force constant of 400 Newton per meter, compressing it to 0.22 meter. So, we have ang katong gi-compress pa ang imuhang spring by the mass. So, na ang event A. Ang event B is when the block is released. Okay, katunang nag-move siya, meaning na wala na siya in contact with the spring. Okay, when the block is released. And event C is maadto na siya sa frictionless inclined slope. So, ito na siya sa incline slope at 37 degrees. So, nanatay 3 events. So, we have to find the speed of the block as it slides along the horizontal surface after having left the spring. So meaning we have to find the speed at point B when the block is released na. Diba? So from point A to point B, so dili gyud ta mag-start sa point A to point B. Dili na to uh, i ko na tong conservation of energy. So we have to evaluate so at point A naa siya, uh, naa siya elastic because na compress man ang spring. Of course wala siya gravity because we have to make a reference level na kaning reference level is the height, meaning the height is 0 here. So basically wala siya gravitational potential energy. Tapos unsa pa may wala, so the kinetic energy also wala siya at point A. Okay, so how about at point B? Unsay naa niya? So kay since all of the elastic potential energy is now converted to kinetic energy, so basically wala elastic, wala gravitational, pero naa siya kinetic energy. Okay, so yeah, we have to find the speed of the block as it released. So we have 1/2 mva squared plus mgha plus 1/2 kxa squared. So a meaning initial na tanan, you have 1/2 mvb squared. I will just erase n mvb squared plus mghb plus 1/2 kxb squared. So the at point A walay gravitational, walay kinetic energy. At point B walay elastic o wala po gravitational kay ground level naman siya. So what's left is this one. So we have 1/2 kxa squared is equal to 1/2 mvb squared. Then find vb. So just have to cancel 1/2. So your vb here is equal to k over m x a squared. So ako siyang square root. Dito na ako. So we just have to review that one if you want. So then put all of the values. So kinsa man pila man ang k. So we have 400 Newton per meter. How about the mass? 2 kilograms. Then the compression spring, a compression distance is 0.22 meters. So that is negative kasi compression man tayo. 0.22 meters. So taking the square root, then squared mo ni siya. So basically the answer is, so dapat negative ni siya ha kay compression man ka. So the answer is 3.1 meter per second. Mo na yung answer. Okay, so next is how far does the block travel up the incline before starting to slide back down? So meaning that how far or what is the maximum height nga na-reach ni block ay ni mass m sa slope. Okay, so meaning that eventually mo stop siya at point C. Okay, so we have to evaluate kung unsay naa sa point C nga energy at saka point B. So sa point B we know wala gyud siya elastic o wala siya gravitational, pero naa siya kinetic energy. Ba? Pero sa point C kay ingom siya how far, meaning at some point mo stop siya, wala siya kinetic energy to find how far or to find the maximum distance na yang na-travel. So wala naman siya spring diri at this event C. So basically wala kay elastic. Pero naman kay height. Okay, kini kuanam siya, this is the height level ha, this is h is equal to 0 kaning ground level. Basically naa siya gravitational. Okay? So then we have to use our So we have to use our conservation of energy. law of mechanical energy. So we have 1 half mvb squared. This is now our point B is now our initial mghb plus 1 half kb kxb squared is equal to 1 half mvc squared. So our point C is our initial. I will just write down all of the ano. So wala kay at point B walay elastic and potential. At point C kay wala kay kinetic energy at saka elastic. So basically ang nag-left lang niya, so we have 1 half mvb squared is equal to mghc. So we have to find hc. But remember, yung hc natin is actually equal to the sine h sine of 37 degrees. Okay, kaya nga naman, because inclined man siya. Diba? So, kung naa kay inclined, so we have to find the height. So, ang height is kani. So, this is like the h sine of 37 degrees. So, you have to put sine of 37 degrees here. Because naka-incline man siya at some angle. Diba? Kay opposite. So, cancel m. So, the hc is just equal to vb squared divided by 2g sine of 37 degrees. So, how much is that? So, you know VB na, di ba? Kay 3.1 na itong VB. I will just calculate here with my calculator. Divided by sine of 37. So, that is 0.81. So, the maximum height na makaya sa imuhang block og abot is 0.81 meters lang. Okay? I think that's it. Then after that, kasi since frictionless man siya, mabalik na pud siya og slide pa dire. Okay? Kay frictionless man siya. So basically, mabalik na siya og slide. Once nga maabot na imong block og 0.81 meters along this slope, so mo stop siya, then mabalik na pud siya, then all of the gravitational potential energy will now increases to kinetic energy, and then kinetic energy will now decreases, then may mo siyang elastic potential, then balik na po siya diri anan. So anana lang. Okay, mo nang gitaw siya, it is reversible. Na kay spring force. Okay, so next, second to the last nga kuan example is actually purely elastic lang siya. Okay? So yeah. So again, wala tay point A, wala tay point B or point C diri. So we have to chop the event. Okay, chop lang. So first, ang una kay gi-compress ang atong spring at distance of 0.20 meters. So that is our event A. So na-compress ang atong spring, compress spring. Nya ato ang event B is when released, the block moves on a horizontal tabletop for 1 meter before coming to rest. Okay, so basically maglibog ta kung atong point B ba is katong nag-move siya or katong nag-rest na siya. So tan-awa ang inyuhang system or tan-awa inyuhang equation, not equation, the problem. What is the coefficient of kinetic friction? So it has nothing to do with speed. So basically, doon lang tayo sa event B sa katong nag-stop ng imuhang block. Okay, so we will let our event B to be katong the block stops. Okay, so yeah, I think this is it. So na di siya frictionless pero na siya friction, tapos na siya elastic or na siya spring. So we have to use this equation. So 1 half mdA squared, 1 half kx squared, kxa squared plus work done by friction, because there is a work other, then 1 half mvb squared plus 1 half kxb squared. Again, mo na. Okay, so next is you have to evaluate. So unsay naa nga energy ni point A, unsay naa ni energy ni point B. So of course at point A, di-compress man nato siya, di ba? So at the maximum compression niya of 0.20, mo stop na siya. Okay, so therefore wala siya work-kinetic energy at point B, point A, o wala po'y, mauta na siya. Okay, so wala lang siya kinetic energy. At point B, atong event B is we let our event B to kato nag-rest na ato ang object. Meaning nga, wala siya kinetic energy, wala po siya elastic potential energy. Wala may spring connected here. Okay, so basically, all of this on the other side of the equation are 0, then this one is also equal to 0. So we have 1/2 kxa squared plus the work done by friction is equal to 0. So ato ang pangitawon is the coefficient of kinetic friction. So remember that the work done by the friction is equal to F S, tapos meron tayong cosine of theta. So here, kaya since straight line motion naman ta, so the angle between the friction at saka displacement is 180 degrees. So we will let a negative Fs. And we know that friction has a magnitude of negative mu k and tapos S, displacement. But what is your N? So again, balik ta sa ato ang free body diagram. So here, ang summation of forces along y is only the normal force at saka its weight, diba? So therefore, ang N nato is just equal to mg. So why is it important to use the Newton's law of motion to give us an expression of normal force? Because not always ng among normal force equal to the weight of the object. Okay, it is very important to know unsa gid ang atong expression for normal force. Okay, so we can put this one here. We have 1/2 kxa squared minus mu k mg, the displacement, is equal to 0. Then we have to put this one on the other side, then divided by mgs. So that is your mu k. Okay, so we have to find the coefficient of kinetic friction. So just put all of the values. So your spring constant is 100 Newton per meter. Then the compression distance is negative 0.20 meter squared divided by the mass, which is 0.5 kilogram. The acceleration due to gravity and the displacement is 1 meter. So from here, padulong 1 meter. That is like the displacement na nakuha ni friction, because ang friction kay nag-work man siya from the start na gyud. Okay? So yeah, basically more na siya. So calculating, so we have 100. So kung na may calculator diha, you can actually so the answer is 0.41. So the mu k is 0.41. And this is unitless. So yeah, that's it. Okay, last problem. Last problem na ta. So the last problem is a combination of conservation of energy at saka projectile motion. Okay, so mao nang gingunta mo nga ayaw ninyo kalimti itong mga na-learn ninyo sa module 1 to 4, because ato na siyang magamit all throughout this course. Okay? So I just have to read the problem. So a child slides without friction from a height h along a curved water slide. So walay friction. She is launched from a height of h/5 into the pool. So meaning that a height h/5 here. So you have to determine the maximum height y if h is equal to 2.5 and the angle is 30 degrees. So here, sa paghawa sa slide sa bata, kabaluta nga iyahang trajectory is like a projectile motion. So we have to find first the velocity of the child na naa siya dali, di ba? So basically at point A, katong napa siya, we have to kanang i-chop-chop na to ang mga event, okay? So at point A, nasa top of the slide ang bata, top of the slide. At point B, naa na siya sa edge of this slide. Edge of this slide. So, from point A to point B, unsa man tong pangitaon dari. So, we have to find the speed of the bata katong nana siya sa point B. Okay? Kaya nga naman, because after getting the speed of the bata at point B, so what will happen? The speed of the child at point B will now become our initial velocity to find the maximum height sa ato ang projectile motion. Okay? So, yeah. So, we have to evaluate muna. So, at point A, naa siya'y potential energy, pero gravitational, dili elastic, wala man tay spring diha nga connect sa bata. So, what else? Wa siya kinetic energy because na naman siya sa top, meaning at rest man siya sa top. An edge of the slide is all of the gravitational potential energy will now converted to like kinetic energy. So, na siya kinetic energy at point P, pero wala siya gravitational potential energy. Assuming kaning reference level here diri na point is mao ni siya ang ato ang kurag height is equal to 0. Okay? Sige, I think mao na siya. Wait. I think we have to also take note of h over 5. Yeah, kasi diba at nasa gravitational potential energy diri, pag-abot diri at this slide, at this our reference point, nahimo siyang kinetic energy. Na musaka nang pud siya balik na h over 5. So naa siya both kinetic energy o potential energy at point C. So naatay tulo ka event. So at point C, ang first is katong ang bata kay naabot sa wait, ako sa ning erase. Katong naabot na siya sa kani bitaw kaning height is equal to 0. Itulo de ka event. So height is equal to 0. And ang event C is katong nanagin siya sa edge of this slide. So atong pangitaon de gyud is the kinetic the speed at point C. Okay. So yeah, so kaon sa nato ang kinetic energy here sa point B diri. So para makaproceed ta sa B to C. So remember, walay friction, so we can directly use 1/2 mva squared plus mgha 1/2 mvb squared plus mghb. So wala siya kinetic energy at point A, wala siya potential energy at point B. So cancel m. So we have to find vb first. So your vb is equal to 2gha square root. Then what is HA? So what is the height? The height is 2.5 meters. So you have to find the height. So we just have to multiply 2, 9.8, then 2.5 meters. And taking the square, there is 7. So yung speed at point B is 7 meters per second. Then padulong na punta sa B to C. So ang point B, we already know nga naa siya kinetic energy pero wala siya potential energy. Pero at point C, naa siya both kinetic energy o both potential energy. Kaya nga naman, naman siya height pod. Yan na pod siya kanang kinetic energy, kinaglihok man siya, of course. So yeah, I think, yeah. So at point C na to is kaning h over 5. Diha nga high potential energy. So this is still the reference level, okay? So na siya both kinetic energy and potential energy at point C. Okay, so we have to find VC. So atong aim dili is atong i-find si VC. Okay, mo man na ang atong initial velocity before siya nag projectile motion, di ba? So we have mg hb is equal to 1 half mvc squared plus mghc. So ang imuhang hb is 0, kanila siya ang 0. So we have to find vc. So cancel m lang kay common mo siya tanan. So we have 1 half vb squared minus 1 half vc squared. So kung siyang gibutan dito sa pikas is equal to GHC. Ay, okay. Ano nga kung siyang gibutan sa pikas? Mo man itong anong, di ba, si VC? So, si VC atong unknown. So, I will just 1 half VB squared minus GHC is equal to 1 half VC squared. So, multiply both sides by 2. So, we have VB squared minus 2GHC, and taking the square root, then we can find VC. So what is your HC man? So HC is basically equal to H over 5 or equal to 2.5 divided by 5. Okay, mo tong height diha. So how much is that? So that is equal to 0.5 meters. Okay, so we will provide. So atong VB, the velocity at point B, pila man siya? So that is equal to 7 meters per second. So we have 7. So 7 squared minus 2 times 9.8 times 0.5. So taking the square root, what is the speed of the child na siya sa edge sa pool? We have here that is equal to 6.26 or 26 meters per second. So I think mo na siya. So now wala pa ta, we have to find the maximum height man. So here atong angle of inclination or katong initial angle sa ato ang bata before siya mahimong projectile, katong nag-projectile na siya amin is 30 degrees. So first, this is our initial velocity, okay, sa ato ang projectile motion. So we have now a projectile. So atong buhaton is we have to find the potential energy. I mean, di na siya potential kaya projectile naman siya. So we have to find the maximum height, diba? So here, kung tanaw na to dari, ato ni siyang extend, bottom ni ang projectile, diba? So kuha na to ang maximum height, ari ra nga part. Tapos para makuha na to si y, is we have to find the maximum height plus h over 5. Okay? So I will just get first the VOX, which is equal to 6.26 cosine of 30 degrees, and the initial velocity along y is 6.26 sine of 30 degrees. So how much na sila? So we have 5.42 meters per second, and the y component is equal to 3.13 meters per second. So how to find the maximum height gani? So at maximum height, we know that the velocity is 0 at maximum height of the projectile. So we can use first Vy is equal to V sub naught y minus gt to find the time it takes para makaabot siya sa maximum height. Diba? So therefore the time sa maximum height is equal to maximum height ani siya sa projectile ha kanira kani. So dili na siya katong total gid na maximum height. So we have here 3.13 divided by 9.8. So we have that is 0.32 seconds. So it takes 0.32 seconds para ang bata maabot sa maximum height siyang projectile motion, then then we, then we can use this expression to find the maximum height. So initially, we can, initial position is 0, so we can take that one as 0. So the y, or the maximum height sa ato ang projectile, is equal to, so v sub naught y is equal to 3.13, and the time is 0.32, then we have 1 half, 9.8, then we have 0.32 squared. So how much is that? So that is equal to, so kung naamoy calculator da, ikuan lang ha. So that is equal to 0.50 meters. So 0.50 meters. So that is the maximum height na kanilang, kana lang siya, kana ngalan niya. So we have to add h over 5. So the h over 5 is equal to 0.5 meters. So ang bata, the maximum height gud nga y is equal to h over 5 plus 0.50 meters. So that is 1 meter. Kasi yung h over 5 natin is 0.50 meter. So morning answer. I think that's the end of the conservation of energy. So next lecture video is all about conservation of momentum. So please, if you have any question, just post it in our PLE or message me directly if you want. So for now, goodbye.